Okay, this is a new type of calculus. Well, it's a new part anyways. Optimization. Sometimes we talk about it as being maximum or minimum calculus because we're in real life problems. We're trying to find out the maximum or minimum values that might help us solve real problems. And there's a structure you can use that can really help you. The first thing, making a sketch, letting x or y equal things you don't know. Make an equation for what has to be maximized or minimized. If there's more than one variable, you've got to put everything in terms of one variable, So that's important. And then you put your equation together and then you differentiate it. And then you make the derivative equal 0, and that's where your min or max will be. Let's look at an example. You've got this farmer and he's going to make a rectangular field, but he's got a big wall. He doesn't have to use the fence. He's got 200 meters of fence he's going to use, but 2 meters he doesn't need. He doesn't need there, but he only needs 3 walls. So you got to build a problem. You got to draw pictures. So you do. You draw a picture. There's the black thing for the wall. There's the red fence you're going to make. It's rectangular. And you make a gate somewhere. You're not going to need that. It's 2 meters. Then you let maybe the width be y. It doesn't matter exactly what letters you use. And maybe let the length be x. And how does it work? How do we find area? We're going to take x and we're going to multiply it by y. We've got the idea of the equation already. Okay, the next step. We can start thinking about building an equation here, but we've got a problem with this y, because y and x together, we got to put everything in terms of x, so we can build an equation. How can we build an equation? Do you know that x plus these 2 y's, they have to equal the 200 in the red and the 2 in the blue. So the x plus the 2y has to add up to 202. Now if you just subtract x and then divide by 2, you're going to get y in terms of x. 202 divided by 2 is 101 minus a half x. Now all we do is substitute. Now we're able to put everything, instead of x and y, we can replace the y with 101 minus a half x. And that's what these notes are about. We have to put things in terms of one variable. We replace the y with this 101 minus a half x. So we multiply it out. There, we've got our equation. Now we're going to find the derivative of this equation. 1 times 101 is 101. 2 times a half is minus 1. And then you always make the derivative equal 0. 101 minus x equals 0. There you go. X equals 101. Well, x equals 101. What will the area be, the maximum area? You just put it back into the equation to get the area. 101 times 101 minus a half times 101 squared turns out to be 5,100,5 square meters. And that's your answer. You've done it. And Mr. Audrey made this nice graph because you can look at this thing and go, oh, it's negative, it's an unhappy parabola, and there's the top of it. Right when x is 101. 101 is like the axis of symmetry. And this 5,100.5 is the turning point right at the top, just to make sense of it, I hope that makes sense.